JEE and NEET faculty. As you can see over here, a question is written. All surfaces are smooth. Find force F such that the block small m remains stationary. Done. So what the question is all about? If this force is not here, if this force is not here, then what will happen to small m? It will slide down because this surface is smooth. If this surface is smooth, this small mass will slide down. But a force F is acting over here, over this surface. What this force will do? This force will somehow maintain this mass to remain stationary. So what we have to solve? We have to find the value of force such that the small block m remains stationary on this surface, and these are the options available here. So how will I have to start? We first have to draw free body diagram. So free body diagram, free body diagram for small mass m. What is free body diagram? We assume the mass, this mass small m, to be concentrated at a single point. Suppose the mass of this block is concentrated at a single point. This is small m. This small m is over the surface here. This small m is on the surface here. So if I'll say how many forces are acting on this small m, primarily there is gravity which is acting downwards. Obviously the gravity always acts downward, so gravity is acting downward. Any other forces? If this angle is theta, as you can see, this angle is theta, so this angle is also theta. Then this is the surface, small m is placed over here. If this is the surface, then perpendicular to the surface, there will be normal reaction. There is a normal reaction, okay? If this is theta, then by vertically opposite angle property, this is also theta. If this is theta, then there will be two rectangular components. First one is in a vertical direction and other one is in horizontal direction. This is the vertical direction, theta is making angle with the vertical direction. So the normal reaction will split into two components, that is n cos theta in the vertical direction because theta is making angle with the vertical, and n sin theta in horizontal direction. Done. Any other forces are acting on this small mass? No, any other forces are acting on this small mass. So if we have to write the equation, if we have to write the net force acting on this small m, then what will be the process? Let us suppose if this mass is here, let us suppose there is a trick. Let us suppose someone is pushing you forward. Someone is pushing you forward. Then that will be your friend. There is a trick. I am using a trick. Then that will be your friend. And if someone is not allowing to go forward, if someone is always taking you back in downward direction, taking you back, don't go away, don't go away, don't go forward, don't go and achieve your goals, then that person should be your enemy. So if someone is pushing you back, then that will be your enemy. So in terms of force, there is a trick. If anyone is pushing you forward, then that will be your friend, and someone is pushing you back, then that will be enemy. That means if any force is taking you in forward direction, then that force will be your friend, and any force which is taking you back, then that force will be your enemy one. So let's use this trick over here. For horizontal direction, for horizontal direction, what is in horizontal direction? N sine theta. This is a force. N sine theta is pushing forward. This mass small m will go in forward direction by this n sine theta. Then what is n sine theta? N sine theta will be your friend. So n sine theta is your friend. Any enemy over here? Any enemy, that means any enemy is pushing this small m in backward direction. No any enemy. That means only friend is here. So no any enemy. That means n sine theta is your friend. No any enemy in backward direction. That's why I'm subtracting here. No any enemy in backward direction equals. If this force is pushing this mass m in forward direction, then where will it go? It will go in forward direction. That means this force is moving this small m in forward direction with acceleration a, because F is acting. So small m will go in forward direction. So this is the trick. So this is the first equation over here. What will be the second equation? That means for vertical direction. For vertical direction, this is the vertical direction only. This is the vertical direction. Who will be the friend? That force which will move you in forward direction. That means n cos theta is moving you in forward direction. N cos theta is your friend. Friend minus enemy. That means enemy over here is mg. Friend minus enemy equals which is going. This mass is going anywhere. In horizontal case, the mass is moving in horizontal direction because of this force. But in vertical direction, this mass is moving anywhere? No. This mass is not moving anywhere, because according to the question, this mass is in stationary position. So this mass must have to be fixed over here. So no any motion in vertical direction. That means no any acceleration in vertical direction. If no any acceleration in vertical direction, that means right hand side will be 0. That means therefore the equation will be n cos theta equals, minus sign will become positive after going in. Then next side of this equation, that will be second equation. We are having two equations, dividing 1 by 2. Dividing 1 by 2. What will happen? N sin theta upon n cos theta equals m into a upon m into g. M will cancel, n will cancel, sin upon cos, tan theta. Tan theta equals a upon g. What will be the acceleration? Therefore acceleration will become g tan theta. This is the acceleration over here. So we have acceleration, and we know what will be the force. Therefore we know force is total mass into net acceleration. Total mass over here is m plus m, and what is the net acceleration over here is g tan theta. So what will be the option? Force is m plus m g tan theta. Option D is correct.